Alright, this video is specifically about the topic of getting calculated dope data and getting it done as quickly and as efficiently as possible, so not consuming too much ammo. I've tried to make this video a couple times, doing like outside demonstrations and things like that, but the videos are never very concise and there's more explaining happening than what needs to occur. So instead what we're going to do is we're going to use the computer to illustrate this point. Before we get into what the computer is going to tell us, first, before you can begin this, you need to ensure everything on your rifle is torqued up, your rifle stock's torqued up, your scope's torqued up, all that type of stuff. Next, you need to ensure that your scope is in fact dead level. Next, you need to measure your sight over bore. Your sight over bore is located right over the action of your rifle, so don't measure the sight over bore too far back on your scope or too far forward on your scope. It needs to be right over the rifle action. Next, you need to have a confirmed 0, and it's 100% reliable. It's not a guess. It's not something you're like, yeah, it's like close. It's not good enough. You need to confirm it. Next up, you need a muzzle velocity sensor of some type that you can reliably get accurate muzzle velocity readings. While doing the test, you're going to want targets spaced out periodically, and you're trying to get as far as you can get reliably, right? So there's a number of factors. Safety, if you can't get out far enough without feeling like you are able to stay aware of the surroundings of that area, make sure that everything's safe. Number 2, wind effects, accuracy limit of your ammo, your rifle, things like that. They'll generate a limit. So for example, I enjoy shooting 22s. They're already quite heavily under wind effects and ammo variation at 300 yards. So trying to get dope beyond that it starts having a lot of air in there, and that's not going to help you improve your data. Next, you need a stable bench to be shooting from. This is not something where you can just be kind of winging it from anywhere, because we're trying to get extremely reliable data, and shooter is going to have some kind of impact on that, and so you're trying to eliminate that as much as possible. You just want the data. You don't want your influence on that data. And then next up, you need some way to verify that you're firing your rifle while the rifle is level. So some kind of something on the rifle mounted to it, so you can verify that the rifle is indeed level when you're firing it. Alright, so let's go ahead, let's take a look at what I put together in Excel for us. So I'm using some of my data from 22 just to illustrate the point. So here I just set up this little thing. You can set up your own, or I'll probably make this sheet here available to other people to use. And so I decided, hey, I want a confidence level of 95%. And so what that means is over here, margin of error 5 FPS, right? So I want just 5 FPS margin of error. And as I start entering the data, you can see here it says needs more data. I enter in the second value. It then starts calculating the standard deviation, how confident we are, right? So currently we're only confidence level 20%. Well, actually 80%, right? 20 remaining. Go ahead and keep shooting, right? And so I just keep entering this data in that I collected months ago. You see it keeps saying, hey, I need more data, and then it says, okay, at the 9th shot here, we've reached pretty good idea of what's going on, and we're within that 5 FPS margin of confidence for what we're doing here, right? So different ammos are going to have different variations in the FPS that they're shooting from. So like a high precision rifle with high precision ammo these numbers are going to be very slim and reliable. Something like a 22, the width can be a lot wider, so I've seen some of the more low-cost ammos coming out well over 100 FPS difference between the highest and the lowest speed shot. And so it's nice to have some kind of system in there that allows you to determine, okay, I don't need to continue testing. I've figured out with pretty good confidence what my actual muzzle velocity is. And within 5 FPS, like, you're going to get a good trajectory on what's going on. And a tiny bit of margin of error like that can easily be swallowed in your coefficient of drag calculation, if that makes any sense. Right? It's just very, very small, 5 FPS. All right, so once you've been able to measure your muzzle velocity to whatever confidence level you're trying to get to, then you can, once you've achieved your far range dope data, you're done, right? So that allows us to utilize our ammo more efficiently. We're not going to be wasting any shots we don't need to. Let's go ahead and take a look at this trajectory spread calculator right here. So what I've done is I've set up this for kind of something you might see from a 6.5 Creedmoor. And so we have pretty high muzzle velocity here, sight over bore, kind of like your standard, probably like low mid scope ring, something that somebody would be out in the field with, where you're not going to want like the super high heavy scope on top of your rifle. It's lower to the rifle, right? So more of like a hunting scenario. So you've confirmed your 0 is at 100. And then what I've entered in over here is different possible ballistic coefficients. So on the low end we have 0.45, 0.47. On the high end we have 0.55. And so what am I trying to demonstrate here is the initial trajectory is all a single line, and as these various ballistic coefficients begin affecting the drag on the bullet, becomes more apparent, right? Initially, even though there is a difference in drag, you can't tell in the first 200, 300, 400, 500 yards of the ammo. Now, let's see. Now we want to kind of describe what's going on and how your BC begins to affect things more and more. And so the trajectory spread, that's what I'm kind of showing in this last graph, widens and widens and widens, and this value gets bigger and bigger the further out you go. So now if you want reliable dope data, and you're, like, I'm within a couple clicks at 400, but you want to be, dead certain, what's the difference? So now we're on my last page. What's the difference between, getting your dope out to 400 yards versus getting out to 1,000? And so here you can see the ballistic coefficient. The blue line is testing at the 400 yards. And so you can see the deviation from what you're looking at is very small, right? So this is less than a click here. And it's hard to kind of tell exactly what's happening when you're testing your bullet at 400 yards. If we go way out, let's send that way out to 1,000 yards. Now, a difference in BC becomes very noticeable. That's 3 clicks, right? That is distinctly 3 clicks at the high end and the low end here. And that's what this is showing, is that you almost can't tell the difference in the BC at 400 yards, but you very much can tell the difference in the BC at 1,000 yards. And so what I'm trying to tell you here is where your efficiency comes from is quickly getting yourself out to, your longest range target that you can test to, because at that point you'll be able to notice if you're 3 clicks off, where at a closer range testing target you won't be able to notice that yet. Once you get that long range data, it immediately creates your trajectory for you, and you know your BC to a high level of confidence that the 400 test will not give you. It's not generating very much confidence. The long range test generates that confidence, and then that your ballistic trajectory is automatically calculated the rest of the way back. So you don't need a ton of testing at any of those other places. All you need to do is, after you've completed your calculated dope chart, is just go back through and verify that what it's telling you is indeed correct. That's all you need to do. And so in this case, if we were to stop testing muzzle velocity at 9 shots, we might have already at the same time been testing and walking our way out towards a 1,000-yard test. So 9 shots, 100, 200, 300, 400, right? So we've gotten out to 900 yards if you're just taking a shot each. And then you do your 1,000-yard, you are going to want to do at least a 5-shot group. You reliably get your dope at that distance. And so now at 14 shots, you've completed your dope testing and you have reliable dope data. That's how you do it very efficiently.